Jai Hind. Our today's topic is combinatorics, one of the part of discrete mathematics unit, fifth unit syllabus. So, in combinatorics, what we are going to discuss are different techniques that are used. So, we'll start with the introduction to combinatorics. Then we will talk about the techniques that we apply when we do the combinatorics. We apply the combinatorics. And at last, we are going to discuss here pigeonhole principle. I'm referring the book Discrete Mathematics and its Applications by Rosen. So now let us start with our topic. So what we are going to talk about is when we do computing, we need to do the combinations, permutations of many of the things. So that is our topic actually, the topic of combinatorics. It is the study of arrangements of object. We are having different object that we need to arrange. So when we study this arrangement of object, that is the area of combinatorics, there are many problems that are addressed in terms of ordered or unordered arrangements. Okay, so when we are having these arrangements, so we need to count how many arrangements are there corresponding to few things. For example, if I am having say two numbers 1 and 2, and if I ask or I decide to arrange them in some order, so I'm having different orders. For example, firstly I take 1, then I take 2. The other thing is I take 2 first and then I take 1. So I'm having two ways to arrange. Same way I am having if 3 numbers, then I am having different arrangements of these 3 numbers. If I take first number as 1, the second can be 2 or second can be 3. Same way I can have first number 2 and second can be 1 or second can be 3. So different possibilities are there. So when we have to talk about how many arrangements are there, how to arrange the things, or what could be the possible ways, that is the area of combinatorics. When we are talking about these arrangements, many problems are solved with help of these. And when we talk about objects, it may be required that the objects can be repeated or may not be repeated. So we can phrase many counting problems in terms of ordered or unordered arrangements of the object of a set with or without the repetitions. These arrangements are called permutations and combinations, and we use that in different counting problem. Let us take a very simple example. Let me say I have to make a arrangement and I have to calculate OR. OR means OR gives us true value if any one of the input becomes true. It will give us false value only if all the inputs are false. So let me take, I am having two inputs. My inputs are A and B. Okay, and what I am going to calculate, that is OR. Now, what could be the possible arrangements of input? That is a problem of combinatorics. We need to count how many input arrangements are there. What could be the input arrangements? Both can be false. One can be false, that is A can be false, B can be true. The other way around, A can be true and B can be false, and the last is both can be true. So I'm having different possibilities of input combination. So I have this counting problem. Same way if so what we have seen here that we are having 4 arrangements. How many inputs were there? 2. So we can see that we are having one input, and corresponding to that one input, there are 2 possibilities. What are those 2 possibilities? True or false. So how many possibilities are there for A? That is 2. Same way we have the second input, The second input is B. What are the possibilities for B? It could be true or false. So what are the possibilities? 2. So total possibilities have become 4. Same way I am having another input, let me say C. So if I am taking ORing of 3 inputs A and B and C, so what is the possibility now? All can be false, 2 can be false, 1 can be true. First can be false, second true, third false. So how many possible combinations are there? A can assume value true or false, 2 chances. Okay, B can have value true or false, so how many chances again? 2. C can assume value true or false, so how many chances? That is 2. So total possible combinations are 8. So that is our topic today, that is the combinatorics. We are going to study the arrangement of objects. So what we are going to cover in this particular topic, those are the counting techniques. So let us start with our basic counting principles here. We have 2 basic counting principles. First one is product rule. So now let us understand what is product rule and where do we apply it. So by the name it is clear, product of 2 things. Okay, so let us consider we are having a procedure. We are having a procedure that can be broken down into sequence of 2 tasks. We are having a procedure that we have divided into 2 parts. Okay, and there are n1 ways to do the first task, and for each of these ways of doing first task, there are n2 ways to do the second task. So we have divided the total work into a sequence of 2 tasks. So first task followed by second task, that is a sequence. First task, then second task. So we are having first task that can be done in n1 ways. Now the second task, which is to be followed after that can be done in n2 ways. Okay, so to complete the total procedure, we are having n1 into n2 ways. This is our product rule. So what is the first basic counting principle? The product rule. When we have sequence of 2 tasks and one can be done in n1 ways, other can be done in n2 ways, then total n1 into n2 ways are there to complete that procedure, to do that work. Second is the sum rule. Now the scenario is different. What is the scenario? We are having a task that can be done either in one of n1 ways or in one of n2 ways. So now we are having different techniques to do. First technique is involving n1 ways to do, and the other thing is there involving n2 ways to do. Okay, where none of the set of n1 ways is same as one of the set of n2 ways. It means all are different. n1 ways are different from these n2 ways. n1 ways to do in one manner, n2 ways are there to do in another manner. Okay, and they do not have anything in common, where none of the set of n1 ways is the same as the set of n2 ways. Then we are having n1 plus n2 ways to do the task. This is called sum rule. So now let us try to understand these with few examples. Now see, the chairs of any auditorium are to be labeled with an uppercase English letter followed by a positive integer not exceeding 100. It means we are having uppercase letters. So how many uppercase letters are there? 26. Which English letters? Okay, we are having 26 English letter, and which positive integers we are taking? Positive integer not exceeding 100. It means we are having 1 to 100 positive integers. Okay, so what is the largest number of chairs that can be labeled differently? So we are having chairs, and those chairs are to be labeled such that we are having English letter followed by a positive integer up to 100. Okay, so this work can be divided into a sequence. What is the sequence? As required. What is requirement? A digit followed by a number, positive integer. So first part is the digit and the second part is the positive integer up to 100. Okay, so firstly we will decide, it can be divided now in two parts. First is what? Deciding the alphabet. What could be the alphabet? We are having how many options? 26. So among these 26 uppercase letter, I can select any one. I have 26 ways to select the English letter. Now what I am having? This is to be followed by a positive integer. Now what could be these integers? It could be integers not exceeding 100. It means up to 100 we are having. So how many ways are there? 100. Product rule, N1 into N2. N1 is the ways to allot English letter. N2 is the ways, number of ways to allot the positive integer. So we are having N1 into N2 ways to do the work. So it is 26 into 100, that is 2600 ways are there to label the chairs. Okay. Another question. We are having 32 microcomputer in a computer center. Each microcomputer has 24 ports. We are having how many computers? 32 microcomputers. How many ports are there for each? That is 24. How 32 are the microcomputer? 24 ports are there in each microcomputer. How many different ports to a microcomputer in the center are? Okay, so what we will apply again, the product rule. We are having 32 computers. Okay, so what are the ways to take computer? 32. You can take any way from the computer. So what we are talking about? We are talking about all the ports. So how we will count the ports? How many are there? Okay, so one way is we'll select the computer. How many computers are there? 32. And on each computer there are 24 ports. So we are having 32 into 24. Okay, so these many ports are there in the center that can be used. So again we have used the product rule. Because what we have done, we have two parts. We have to take the computer, we have to count the computer, and then from each we have to consider port. So how many ports are there that we can take? That is 32 into 24. Another very important question. How many functions are there from a set with m elements to a set with n elements? Okay, so what we are counting? We are counting the number of possible functions. What is a function? A function is a mapping from one set to another set. Okay, what type of mapping it is? Each element of A should have unique image in B. Okay, so now when I am saying each element, so how many elements are there? So in A I am having m elements, that is 1, 2, 3 up to m. How many elements are there? M. Okay, and where the image will be? In B. From B it can take an image. How many elements are there in B? That is n elements. So how many elements are there? 1, 2, 3 up to n elements. So what is a function? Function is one mapping in which each of these m elements, how many elements are there? M. Each of these m elements, there will be one image in these n. From these elements, we will assign one image to these elements. Now, if I talk about these elements, what is my first element? Let me say element 1. So 1 is having the option of 1 as image, 2 as image, 3 as image, n. So here we are having m elements, here we are having n elements. So these can be, one can be assigned any image from 1, 2, 3 up to n. So how many ways are there? So firstly what I am doing? I am dividing my job into assigning images to each and every element. Okay, so first part is I'm assigning image to 1. 1 ko I can assign any image from these n elements. So how many ways are there? N. Then 2 can be assigned any image from here. So how many ways are there? N. 3 I can assign any image from here. So n. Up to m elements. Okay. So m can also be assigned any image from n. So what is the number of possible function? N to the power m. Because there is no condition. Any image, any element from here can be assigned some image from here. And what is the available options? N elements. Okay. So 1 can have any possibility of image from n elements. 2 can have any elements, any image. So we are having how many possible function? N to the power m. So we are having n to the power m functions from a set with m elements to a set with n elements. If we make a change, what type of change? If we want one-to-one functions, one-to-one function. The first point is we cannot have a one-to-one function from here if n is less than m, because 1 to 1 means 1 should have different image, 2 should have different image, and so on. One element cannot be image of 2, then it will be 1 to 1 function. Okay. So if n is less than m, then there will be some element which is not having any image. So what is first condition to be 1 to 1? N should be greater than equal to m. If n is less than m, then we cannot define such function. Okay. Now see, when we are saying one-to-one function, so what is the definition of one-to-one function? One element cannot be image of, one element from this set cannot be image of 2 elements from this set. It should be different. Okay. So what does it mean? No repetition. The repetition is not allowed here. Here we were having repetition. What type of repetition? If 1 is image of 1, we took n ways to do. Again we are saying ki yes, 1 can be image of 2 also. That's why we said that we can have, the element can have n images again. 3 can have n images again, and so on. So now we are removing this condition. So I'm talking about 1 to 1. When I'm saying 1 to 1, it means 1 is having the option of any one image from these any elements. But what happened now? We need one-to-one function. It means the one which we have assigned to 1 will not be assigned to 2 now. It means now how many options are there for 2? N minus 1. Now 2 elements have been assigned. How many options are there for next element 3? 2 options have already gone. So n minus 2. To 4, n minus 3. And so on. And what will happen to m? What will happen to m? M minus 1 options have already been used. So others can be image to this. So this is the number of possible function of which type? 1-to-1 type. Number of possible functions are n to the power m, but number of possible m to m functions are n into n minus 1 into n minus 2 into n minus 3 up to n minus m plus 1, where n is the number, where m is the number in first set and n is the number of elements in the second set. Okay, so this way we can count the number of possible functions. Yes, basic counting we are doing using the principles of product rule and sum rule. Now we are having another question. A student can have a choice of a computer project from 3 lists. The lists are having 23. One list is having 23 options of projects. Second is having 15 and the third one is having 19 possible projects. no project is on more than one list. It means all the projects are different. How many possible projects are there to choose from? So a student have to choose the project from one of the list, and how many options are there on those list? First is having the 23 option. It means it is one way of doing the thing, or the student can choose from second list. In second we are having 15. So these are different ways of doing. So we are not using product rule. What is product rule? In which we have divided our work into parts, into sequence. Okay, and that sequence is to be the ways to do that sequence is to be parts of the sequence is to be multiplied. But here we are having either option. So what we will apply? We will apply the sum rule. So we are having 23 project option, 15 projects option, and 19 projects option. So accordingly, we will have the total number of options to do this work. It will be these many ways to do the job. Okay, we can select among these many projects to sum it up. Total will be 57. So we are having these many projects, okay, and that we can use to select the project. All are different. That's why we have summed up. Now I have taken one example from the given text of Discrete Mathematics by Rosen for a C program. For a program which is having loop. Okay. So now on this particular slide, I have taken two loops. What is the first loop saying? The first is saying that we have to count the number of times the loop is running. So what it is saying, for k is equal to 0, we are using to find the final number, how many times the loop has run. So what we are having for I1, that is the first for loop, we are having 1 to n1 ways. So this we have to do n1 times. Now we are having nesting of loops in this. In these n1 times I1 index, we are having this loop which is to be run at n2 times. And so nesting we are having, and what is the innermost is doing? It is running nm times. It means for these n1 times, these loop will run. Within this n2 times, this loop has to run, and within these loops has to be run. And every time we are running the loop, we are incrementing the value of k. Okay, so how many times it will run? How many times it will run? K will get incremented. So what will be value of k at end? So this is our counting problem. What we are counting? The number of times this statement has executed. That we have calculated in k. The number we are storing in k. How many times this k is equal to k plus 1 has executed? So the outer loop is running n1 times. In this loop, its inner loop is running n2 times. In that inner loop is running n3 times, and so on up to the innermost. How many times the innermost is running? That is n into m. So what we need here, product rule to find out. Okay, that is the value of k. Now if I see this snippet, if I see this code snippet, in this again I am having k0. Okay, and we are finding the value of k. Now see what is happening. This loop is running n1 times. It means k is incremented n1 times. Now this has terminated. Now second loop is running, and that is running n2 times. Then next is running. So what this particular loop is doing? It is incrementing the value of k to n1. It is getting at end, the value of k will be n1. Now again, k is incremented n2 times, so it will become n1 plus n2. And so on. In last, what will happen? It will become n1 plus n2 plus n3 up to nn. So this nesting is making product rule, and this is making OR. Here all the for loops are different. One is terminating, then second is starting. Then second has terminated, third is starting, and so on. So this is the counting of the k value. We are using combinatorics to find the k value. Here we have applied the sum rule, and here we have applied the product rule. Why we are applying the product rule? Because these are nesting in one another. These are nested loops, and these are independent loops. Nothing is in common. Now we'll talk about the rule of subtraction, that is inclusion, exclusion for two sets. Okay, so what the rule is called? Subtraction rule. If a task can be done in either n1 ways or n2 ways, then the number of ways to do the task is n1 plus n2 minus the number of ways to do the task that are common to the two different ways. Okay, so what we are having here? We are having the method of addition of first with the second number of ways, but there may be something in common, so that we have to exclude. Let us understand this with an example. I have to find out the bit string. How number of bit string, the counting of bit string, how we are counting the bit strings? Length 8 either start with 1 bit. So either it is starting with, what is the length? That is 1 bit. So it is what is the length? 8. It is starting with 1 bit. It means first bit is fixed, but other 7 bit could be anything, 0 or 1. So I am having options for second, third, fourth, fifth, and so on up to 8th bit. Okay, it means how many ways are there to do this? 2 power 7. 7 bits can be anything, 0 or 1, but first bit is not having the option of 0. It is starting with 1. Okay, now what is the second condition? OR. What is the second condition? OR end with 2 bits 0, 0. It means last 2 bits will be zeros. Other 6 are having option. What option? It could be 0 or 1, 0 or 1, 0 or 1 up to 6. Okay, so what is the possibility? So what we are talking about, all the bits starting with 1 bit have 2 to the power 7 possibilities. All the bits with last 2 zeros have the possibility of 2 power 6. Okay, so this is the total number we can find out. But what is the problem here? It has also included those bits which are starting with ones and ending with zeros. For example, this particular first bit is 1, last 2 bits are zeros, and this is remaining 5 bits. So this we have counted here also, and this we have counted here also. Okay, so these type of bits have been counted twice, so that we need to subtract. This is the principle of inclusion and exclusion. We are including all in A1, we are including all in A2, but we are excluding those which are present in both. It means the strings which are present here and here both have been counted twice, so we need to subtract once. This is the rule of inclusion and exclusion. Okay, so in this particular lecture, we have talked about 3 rules: the sum rule, product rule, and subtraction rule. In the next lecture, we'll continue from here. and we will talk about the remaining part, that is division rule and pigeonhole principle. Thank you. Jai Hind.